In this video, we're looking at some AP style practice questions on limits. And notice that on these questions, a graphing calculator is allowed. So before you continue watching this video, make sure you've got your graphing calculator handy. On question number 15, it says, based on a graph, what is the value of the limit as x approaches 0 of x to the negative x? So since we have a calculator, let's graph that function x to the negative x. If you graph that function, you end up with a graph that looks something like this. On the left side of 0, the graph is, whoops, I was going to change colors. The graph is oscillating back and forth. It's hard to tell what it's doing. It's going back and forth, and at 0 from the left side, there would actually be no limit. But on the right, things tend to smooth out, and the graph goes something like this. And if you zoom in on that point there at x equals 0, right here you can see that this value is equal to 1. And so since we are only considering x approaching 0 from the right, only considering this part of the graph, then our answer is B. The limit from the right is equal to 1. Next question, similar to that one, based on a graph, what is the value of the limit as x approaches 0 of sine of 3x over tangent of 2x? Well, if you graph this function, it's actually a very interesting graph. It looks like this. Whoops, actually touches the axis. Let's try that again. There we go. But then that same pattern repeats over and over again, which hopefully you should expect some repetition of a pattern because we're dealing with periodic functions here, sine and tangent. But in this question, I'm only interested in what the function is doing as x gets really close to 0. So as x is approaching 0, my function on both sides is approaching this value right here. And if you zoom in on that value on your graph, you can see that it's at I didn't really leave myself room to write it. It's at 1.5. And so our limit here is equal to 1.5 or 3/2. Let's look at the next graph. Describe the behavior of f of x equal to this function as x becomes large and positive. Now as x becomes large and positive, that's just another way of asking us to find the limit as x is going to positive infinity of this function. And so we could work this like we normally work functions as x goes to infinity, as we work limits as x goes to infinity without a calculator. I could divide everything through by x cubed and we could figure out what this is equal to, but we have a calculator. And so if you go to your calculator and graph this function, you can see on the graph in the standard viewing window, there certainly seems to be a limit. The graph is a little weird, but what I'm seeing on my calculator looks something like this. And so this part over here on the left of 0, it looks a little bit crazy, but that part doesn't matter because what I'm interested in is what's happening as x approaches infinity, which is out here. And it certainly looks like we're leveling off, like we're reaching a horizontal asymptote. So if you zoom in a little bit on your graph, you could kind of guesstimate, just based on the answers that we have here, that horizontal asymptote is happening at 3/2. Let's look at all of our answers. First of all, answer A. As x becomes large and positive, or as x goes to infinity, do the function values become large and positive also? Do they go to infinity? Well, no. We can tell here that they're leveling off at some particular value. I do have a horizontal asymptote out there, and so this is not the right answer. Do the function values approach 0? No. Obviously, it's positive. I'm going to skip answer C because that's the one we think it is. Answer D, do the function values approach 1/3? Well, no, if you look on your calculator screen, you can clearly tell that the horizontal asymptote is something greater than 1. So 1/3, that can't be the answer. Do the function values approach 9/2? Well, 9/2, that's like the same as 4.5, and the horizontal asymptote is obviously not that high just by looking at the graph. And so we've eliminated the other answers. Our limit, our horizontal asymptote, as x goes to infinity, it is at 3/2. All right, on this question, describe the behavior of f of x equal to e to the negative 1 over x as x approaches 0. Now if we graph that graph on our calculator, again, get another interesting looking graph here. On my calculator, I see a graph that looks something like this. That's what I see on my calculator screen. So let's look at our answer choices and see if we can happen. I want to know the behavior of the function as x approaches 0. So that's another way of asking us, what is the limit of f of x as x approaches 0? Well, if I'm approaching 0 here on the left side, it looks like my function is continuing on up to positive infinity. And as I approach 0 here on the right side, it looks like my function is coming down to approach a value of 0. So let's look at our answer choices. Answer choice A, the limit as x approaches 0 is 1. Well, if we look at our graph, obviously that is not true. The limit doesn't exist. And so since it doesn't exist, it can't equal 1. And by that same logic, we could also cross out answer E, the limit as x approaches 0 equals 0. That's not possible because there is no limit. So then I'm left with these middle choices. Limit from the, as x approaches 0 from the right of f of x equals 1. Well, that's not true. From the right, it looks like we're approaching 0. Limit as x approaches 0 from the right is infinity. Again, not true. So hopefully D is true. This is the one I'm left with. The limit as x approaches 0 from the right is 0. That certainly seems to be true in our graph. And the limit as x approaches 0 from the left equals infinity. That certainly seems to be true in our graph. And so the answer is answer D. Final question on this video. Suppose that the limit of f of x as x approaches 3 is equal to the limit of h of x as x approaches 3. And that's equal to 18. So I've got two limits as x approaches 3, two functions as x approaches 3, and they both have a limit of 18. And then we have this statement, f of x is less than or equal to x squared times g of x, which is less than or equal to h of x for all values of x. So that's a really complicated way of saying that this function, x squared times g of x, is between f of x and h of x always, for all values of x. So if that's true, then which of these following statements are true? If the limit of g of x exists. So I do have a limit at g of x. I'm sorry, the limit of g of x as x approaches 3. That's important. So that limit exists. So first of all, part 1 says the limit as x approaches 3 of x squared times g of x has to equal 18. Well, let's consider our two statements up here. First of all, the limit of f of x as x approaches 3 and the limit of h of x as x approaches 3, those are both equal to 18. And then notice this statement, which I've already underlined, x squared times g of x is between or equal to f of x and h of x. And so I'm going to rewrite that statement over here. F of x less than or equal to x squared times g of x less than or equal to h of x for all x's. So if I'm talking about at x approaching 3, well, we've already said that this limit is equal to 18, and we've said that this limit is equal to 18. That was given to me in the question. So hopefully it makes sense to you that this limit would also have to equal 18. That all of these things would have to be equal to each other. Because if x squared times g of x is between f of x and h of x or equal to them, my only choice here is that they all be equal. Because there's nothing between 18 and 18. It has to be equal to 18. And so statement number 1 is true. All right, let's look at statement number 2. The limit of g of x would have to equal 2 as x approaches 3. The limit of g of x as x approaches 3 equals 2. Well, remember, if I want to find a limit as x approaches a value, I should substitute in that value. So I'm going to take this x squared times g of x, and I'm going to substitute in the 3 for x squared. I get 3 squared times g of x, which is 9 times g of x. And we already discovered in statement number 1 that the limit of this whole thing, the limit as x approaches 3 of this, is equal to 18. So if 18 is equal to 9 times g of x, then g of x must be equal to, I'm running out of room over there, sorry, g of x must be equal to 2. And so this statement is also true. Finally, erase what I just did. The limit as x approaches 3 of x times g of x would have to be equal to 6. Well, if statement 2 is true, limit as x approaches 3 of x times g of x, I would be substituting in the 3 for x, and then in statement 2, we determine that the limit as x approaches 3 of g of x is equal to 2. So where g of x is, I could substitute in 2, and 3 times 2 is equal to 6. And so our final statement is also true, and therefore the correct answer is answer E.